किस काम के होने के कितने चांसेस है, राइट। फिर हमने कुछ बेसिक टर्म्स डिस्कस करी प्रोबेबिलिटी के अंदर, लाइक सैंपल स्पेस। वैसे तो हम 11th क्लास में ये सब पढ़ के आए थे, जो भी मैं भी बता रहा था। सैंपल स्पेस हो जाता है कि जितने भी पॉसिबल आउटकम्स आपके होंगे, सैंपल स्पेस को आप हमेशा एस से दिखाएंगे। सबसे पहले तो हमने डिस्कस करा था, सॉरी, एक्सपेरिमेंट। और एक्सपेरिमेंट में भी दो तरीके के एक्सपेरिमेंट होते थे, पर हमारे काम का है रैंडम एक्सपेरिमेंट। और रैंडम एक्सपेरिमेंट वो एक्सपेरिमेंट होते हैं जिनके अंदर हमें आउटपुट का पता नहीं होता, हमें टोटल पॉसिबल आउटपुट पता होता है, बट ये नहीं पता होता कि कितने, क्या आउटपुट आने वाला है। तो मैं एक डाइस का केस ले लेता हूँ, उससे ही सारी बातें, सारे फटाफट से सारे एग्जांपल समझा देता हूँ। तो डाइस को जब हम थ्रो करते हैं तो एक रैंडम एक्सपेरिमेंट होता है, क्योंकि हमें ये तो पता है कि क्या क्या आंसर आ सकते हैं, 1 2 3 4 5 6, बट क्या आएगा, एग्जैक्टली क्या आएगा इन 6 में से, हमें नहीं पता। So this type of experiments are known as a random experiment, in which all the possible outcomes are known to us, but we don't know the exact output, right? हमें नहीं पता 1 से लेकर 6 के, आप ये नहीं कह सकते श्योरिटी से कि हाँ जी आप थ्रो करोगे डाइस और 4 ही आ जाएगा, नहीं, पता नहीं, 1 से 6 तक कुछ भी आ सकता है, आई मीन। और अगर आप सारे पॉसिबल आउटकम्स लिख के और उनको सेट के अंदर लिख दो ऐसे, तो ये सैंपल स्पेस हो जाता है। यानी कि एक डाइस के लिए सैंपल स्पेस है S इज इक्वल्स टू 1 2 3 4 5 6, यानी कि जितना पॉसिबल सेट ऑफ ऑल पॉसिबल आउटकम्स। सैंपल स्पेस के बाद हमने डिस्कस किया इवेंट्स। तो आप कोई भी काम कर रहे हो वो एक एक्सपेरिमेंट है। अगर उस काम को करते हुए आपको ये ना पता हो कि आउटपुट क्या आने वाला है, तो रैंडम एक्सपेरिमेंट है। फॉर एग्जाम्पल थ्रोइंग अ डाइस। अगर किसी रैंडम एक्सपेरिमेंट के सारे आउटकम निकाल लो, यानी कि सारे आउटकम्स को लिख दो सेट की फॉर्म में, तो सैंपल स्पेस बन जाता है। अब इस एक्सपेरिमेंट के अंदर जो भी होगा वो इवेंट बोला जाएगा। फॉर एग्जाम्पल, अब मैं इसके कुछ इवेंट बनाता हूँ। लेट्स से इवेंट को आप हमेशा कैपिटल लेटर से डिनोट करते हैं। तो ए एक इवेंट है, हमने पिछली क्लास में भी यही बनाया था, गेटिंग एन इवन नंबर। बी एक इवेंट है, गेटिंग एन ऑड नंबर। तो अगर आपसे कोई पूछे कि भाई गेटिंग एन इवन नंबर, एक डाइस है, उसके लिए इवन नंबर क्या क्या होंगे, 2 4 6। अगर गेटिंग एन ऑड नंबर ये इवेंट बनाया जाए तो इसके फेवरेबल आउटकम्स हो सकते हैं 1 3 5। 3 ऑड नंबर है सैंपल स्पेस के अंदर, 1 3 एंड 5। इस तरीके से हम इवेंट्स बना सकते हैं, यानी कि एक्सपेरिमेंट के अंदर जो भी बात कर रहे होंगे वो इवेंट्स बन रहे होंगे। अब इवेंट्स के कुछ टाइप्स होते हैं। जो भी सैंपल स्पेस के अंदर आंसर्स आए, आउटकम्स आए, उसको आप सैंपल पॉइंट बोल देते हैं। सैंपल पॉइंट, सैंपल का कोई पॉइंट है। अगर आपका इवेंट के अंदर एक ही सैंपल पॉइंट यूज होता है, फॉर एग्जाम्पल मैंने एक इवेंट बनाया सी गेटिंग 2, मतलब मुझे 2 चाहिए इसमें से बस। पहली बार कह रहा था इवन नंबर चाहिए, तो आपने कहा 2 भी मिल सकता है, 4 भी मिल सकता है, 6 भी मिल सकता है। दूसरी बार बोला ऑड नंबर चाहिए, आपने कहा 1 3 5, तीनों में से कुछ भी मिल सकता है। तीसरी बार आपसे कहा जा रहा है सी एक इवेंट है जिसमें कह रहा है कि 2 चाहिए, तो आपने कहा 2 इसका फेवरेबल आउटकम। फिर डी एक और इवेंट बनाया गेटिंग अ प्राइम नंबर। गेटिंग अ प्राइम नंबर की बात करें तो 2 3 एंड 5। 1 इज नॉट नाइदर अ प्राइम नंबर नॉर अ कंपोजिट नंबर। इस तरीके से हम इवेंट्स बना सकते हैं। तो सबसे पहला सी इवेंट देखिए, सी के अंदर सिर्फ एक सैंपल पॉइंट आया है। आप ए के अंदर देख रहे हैं 3 सैंपल पॉइंट है। बी के अंदर भी 3, डी के अंदर भी 3 सैंपल पॉइंट है, बट सी के अंदर सिर्फ एक सैंपल पॉइंट आया है। तो इस तरीके के इवेंट को सिंपल इवेंट बोल देते हैं, जिसमें सिर्फ एक ही सैंपल पॉइंट हो, और जिसके अंदर एक से ज्यादा सैंपल पॉइंट हो, ऐसे इवेंट को कंपाउंड इवेंट बोल देते हैं। कंपाउंड इवेंट। अगर दो या दो से ज्यादा इवेंट्स ऐसे हों कि जिसमें कुछ भी कॉमन ना हो, फॉर एग्जाम्पल ए और बी को यहां पे नोटिस करो, ए के पास 2 4 6 है, बी के पास 1 3 5 है, ए और बी में कुछ भी कॉमन नहीं है। याद करिए, ये वाला सिंबल होता था इंटरसेक्शन, कॉमन निकालने के लिए, पिछले साल सेट्स में पढ़ा, कॉमन निकालने के लिए ए इंटरसेक्शन बी। तो अगर आपका ए इंटरसेक्शन बी कहीं पे भी 5 हो जाता है, मतलब दो इवेंट्स के बीच में कुछ भी कॉमन ना हो, म्यूचुअली एक्सक्लूसिव बोलेंगे, म्यूचुअली एक्सक्लूसिव। फॉर एग्जाम्पल ए और बी यहां पे म्यूचुअली एक्सक्लूसिव। क्या आप मुझे बता सकते हो कोई दूसरा पेयर ऑफ इवेंट भी है क्या जो म्यूचुअली एक्सक्लूसिव है? कोई और भी पेयर ऑफ इवेंट्स है ऐसा जो म्यूचुअली एक्सक्लूसिव हो? एक ए और बी तो हमें दिख रहा है, ए और बी के बीच में कुछ भी कॉमन नहीं है। एनीवन? एक म्यूचुअली एक्सक्लूसिव इवेंट का पेयर मुझे दो ना, इसमें से है? बी और सी चेक करो। देखो, बी के पास 1 3 5 है, सी के पास सिर्फ 2 है, तो बी और सी भी यहाँ पे म्यूचुअली एक्सक्लूसिव। तो दो या दो से ज्यादा इवेंट्स अगर कुछ भी कॉमन एलिमेंट ना रखते हो, तो यू कैन इजीली से दैट दीज आर म्यूचुअली एक्सक्लूसिव इवेंट्स। एक और नाम बताया गया था म्यूचुअली एक्सक्लूसिव का, इफ यू रिमेंबर, डिसजॉइंट। डिसजॉइंट इवेंट्स, ये डिसजॉइंट सेट्स होता है वैसे तो।
Sir,
हाँ जी।
can you teach in English?
अरे यस नासिर। Nasir, from where do you belong, by the way? Just asking.
Tamil Nadu.
Okay. Okay, so mutually exclusive or disjoint events are basically those events in which there is no element common. Whenever we have two or more sets in which there is not a single element common, you will not find any element common in those events, then you can safely say that these events are mutually exclusive. And one other name for mutually exclusive is disjoint events. Disjoint is the term used for sets initially. Disjoint sets. Disjoint sets are those sets which have nothing in common. But we can extend this to events as well. Like we can call two or more events disjoint if they have nothing in common. So here A and B as well as B and C both are pair of mutually exclusive events or disjoint events. Then we studied mutually exhaustive. Mutually exhaustive events. So what was mutually exhaustive events? Same, two or more events. Minimum two, maximum you can have any number of events. Two or more events in which you have have their union equal to the sample space. In simpler terms, if you combined both of them, if you combined two or more events, such that they cover all the sample points. For example, take A and B. If you take union of A and B, means that take all the elements of A and take all the elements of B, but don't repeat any element. So if you take all the elements of A, it's 2, 4, 6. If you take all the elements of B, it's 1, 3, 5, and no element is repeating. So basically, we can take the union directly as 1, 2, 3, 4, 5, 6, which is equal to your sample space. So you can say that A and B are exhaustive set of events. Mutually exhaustive events, yeah, exhaustive set of events. So when two or more events exhaust all the possibilities, all the possible sample points, they are known as exhaustive set of events. Maybe two, maybe more than two, maybe three, four. So however number of events constitute or add up to your sample space are known as exhaustive set of events. So whenever you want to check whether these events are exhaustive or not, just take union. For example, let's take union of B and C. If you take the union of B and C, it will simply be 1, 2, 3, 5. We don't have 4 and 6 here. If you take A union C or B union D, let's find out these elements are let's find out these events are exhaustive or not. So if I talk about A union C, A union C will become 2, 4, 6. A is 2, 4, 6, C is 2, which has already been in written, which has already been in A. So we don't repeat any element while writing a set. Hence, A union C should be 2, 4, 6, which is not equal to sample space. No. So I cannot say that A and C are mutually exhaustive. Similarly, take B and D. If I take B and D, so D has 2, 3, 5, but 3 and 5 are already in B. So there's only one new element, 2. So 1, 2, 3, 5. This will be the union of B and D, which is not equal to S. Hence, A and C are not exhaustive set of events. Similarly, B and D are not mutually exhaustive. So whenever union of two or more events, two or more sets is equal to sample space, these events are known as mutually exhaustive. Now, another term, equally probable. Just a minute. Okay. Can I remove this? If someone hasn't written, to tell me. Okay, there's space. Okay. So next is equally probable events. Suppose you toss a coin. Okay. What is the probability of coming out head? Toss a coin. What is the probability that head will turn out?
1/2.
1/2. And what is the probability that tail will turn out?
Same 1/2.
Same, 1/2, right? So the any event is called equally probable. The equally probable events either or equally probable outcomes is same if it means the same if every outcome has equal probability, then it is known as equally probable event. Like tossing a coin is an equally probable event until unless the coin is fair, unbiased. So there will be more terms used as biased, not biased, unbiased, or fair. Both are same. Unbiased or fair is that it isn't favoring anyone. Unfavorable. Like in this case, head and tail. Head and tail both have equal probabilities. We are not favoring anyone or any side out of head and tail. So it's an unbiased coin or fair coin, right? Then we also had one more thing, complement in sex. So complement means not. It means not. It is not that complement. The complement of maths nouns means that not. So if I write a complement, now first of all, how will I write a complement? Either by this, by giving this bar on any event, or by dash, or just by writing AC. So this is complement, which means not A. We don't want A. So let's say this is a universal set, and this is an event A. So A complement is equals to universal set minus A. That is, we don't want A, but whatever is left after leaving A, we want that. So if I calculate A complement, it will be all the possible, or all the universal set, that is sample space, basically, sample space minus the event A. So this was complement. These were some of the basic terms which you need to know. Now coming to the first topic of 12th class. The first topic in 12th is conditional probability. Okay, can I remove this, guys? If someone hasn't written, he or she may raise that. Okay. So coming to the first topic is conditional probability. So we are going to learn some new things. We haven't learned anything new in probability yet. I mean, like till 10th, though, it was all same. Hasn't changed much. But in 11th, we used set theory and PNC in probability. Now in 12th, we'll be doing some more things, some new things. So first is conditional probability. What does that mean? We have to find the probability after putting a condition. For example, let's take this example. I'm throwing 2 dice. Can you tell me what is the sample space? Like, tell me some elements of the sample space. Give me 2-3 elements of the sample space. When I throw 2 dice, what is my sample space? You can start with 1-1. If both die have 1-1, then 1-2, then 1-3, and similarly 6-6. Right? So number of elements in sample space is 6 square, which is 36. Now, out of these 36 elements, okay, let me show you these elements first. So this one example will be in itself be enough to give you guys a hint about what is conditional probability. Just listen to it. It's also given on Wikipedia, by the way. The same example. When you search conditional probability on Google, the same example is given on Wikipedia. Okay. So these are the possible set of outcomes. 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 3, 1, 4, 1, 5, 1, and 6, 1, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 3, 3, 3, 4, 3, 5, 3. I want to ask you a lot of questions out of this, okay? 6, 3, 2, 4, 3, 4, 4, 4. Do you know what a doublet is? Nasir, do you know what a doublet is?
What is it? Say again.
Doublet. Doublet. Do you know what a doublet is? Like triplet. There is a term called doublet.
You mean 2, 2, 3, 3, 4, 4, like that?
Yeah. Okay, so these are 36 possible outcomes. Okay. Now I'm telling you, I'm asking you a question. Okay. What is the probability that first dice has 2? What is the probability that I throw 2 dice and the outcome on first dice is 2?
6 by 36.
6 by 36, right? Okay. Now I'm asking you another question. What is the probability of getting 2 on first dice if the sum is 8?
One by 36.
Why 1 by 36? Like you
Because
think
sum
one
is 8,
case
no?
is favorable, right? 2,6.
Yeah,
And
only
there are
that.
36 cases.
Yeah.
That's what you showed, right?
Yes, sir.
But there are not 36 cases this time, Nasir. You have been given that the sum on the numbers of the dice is 8. So if the sum of the numbers is 8, you only have to consider those cases in which the sum is 8. I mean, there are 36 elements, but they all don't have the sum 38. This one has sum 8. This one has sum 8. This one has sum 8. This one also has sum 8. This one also has sum 8. There are 5 boxes which have sum equal to 8, in which there is only one possibility which contain 2 on first dice. So we haven't been asked that what is the probability of getting 2 on first dice. We have been asked that we want the probability of getting 2 on first dice, but in the case when the sum is 8. So they have already applied a condition here. And that condition matters. Because what happened after that condition is that we reduce our sample space. Now our sample space is according to that condition. We only have 5 possibilities in which the sum is 8. There were 36 cases. No, we are not denying that. There were 36 cases. But all the 36 cases didn't have sum 8. So we'll only consider those cases in which the sum is 8, which are like 5 cases, in which the favorable outcome is on one case. Only one box contained 2 on first dice. So the probability of getting 2 on first dice when the sum is 8 is 1 by 5, while the probability of getting 2 on first dice is 6 by 36. These are two very different conditions. How can we define conditional probability now? Conditional probability is just like that. Whatever we did here in this example, conditional probability is going to work like that. So we write this, first of all, let's understand the representation. We write this like this: PA by B. PA by B. Which means that probability of A, we need to calculate probability of A when B has already happened. Probability of A when B has already happened. Means B has already happened, B has already occurred. Now set B will decide your sample space. That is the first change. Set B will decide what should be our sample space. Like what should be the total cases. Because we want the probability of A according to the set B. Just like we did in this case, we wanted to know the probability of getting 2 on first dice, but when the sum was 8. Hence the probability was 1 by 5, because there were 5 cases only in which the sum was 8. So there will be an event A whose probability we need to find, and there will be an event B who has already occurred, who will decide our sample space. Decide sample space. Now, how will we calculate this? Probability of A by B is nothing but probability of A intersection B divided by probability of B, which can also be written as number of elements in A intersection B divided by number of elements in B. Now you'll get this very easily. Just come with me. Let's come to the example again. So the event A was getting 2 on first dice. We wanted to know the probability of getting 2 on first die. While the event B was getting the sum 8. How did we solve it? There were 6 outcomes in which 2 was on the first dice. 2-1, 2-2, 2-3, 2-4, 2-5, 2-6. Just listen to me very carefully. Did you understand the example? Nasir, did you understand the example?
Yes, sir.
Okay. Okay, so I'm filling the boxes. I'm filling the boxes of event A. Event A is getting 2 on first die. Event B was getting the sum 8. So event A is this, in which I have blue colored. I have colored blue all the elements which belong to event A. Event A was getting 2 on first die, so 2-1, 2-2, 2-3, 2-4, 2-5, 2-6. Now event B is getting the sum 8. I'm filling some other color in this. Getting the sum 8 means this one. Oh, sorry. Okay, I can use this. This one, 2-6, then 3-5, then 4-4, then 5-3, then 6-2. Right? There were 5 possible outcomes in which the sum was 8. What now? Coming to my question, what did I need to find here? I wanted to find the probability of A when B has already happened. Means that I wanted to find the probability of getting 2 on first die when the sum is already 8. When the sum of the numbers on the 2 dice is 8. So sum on the 2 dice is 8 in 5 cases. And getting 2 on first die has 6 cases. But there was only one case in which the sum was also 8, as well as sum was also 8, as well as the number on the first dice is 2. We told this the probability is 1 by 5 because we can easily calculate this with the example. But now coming to the technicalities, what was this 2,6? This was the element who belongs to both the sets. Intersection. Intersection B. So 2,6 was the only element which was present in A as well as in B. Hence, why did we took this one as favorable outcome? Our favorable outcome was 1 only. Why? Because it was in both sets. It was in A as well as in B. Because in this case, the sum was 8 as well as the number on first dice was 2. It was intersection of both sets. So probability of A by B, that is probability of A when B has already occurred, is number of elements in A intersection B divided by number of elements in B. So these were A intersection B, then this was B. This B contained 5 elements. The probability was 1 by 5. Hence, this formula. But remember this is important. Conditional probability is we're gonna use this extensively. Should we proceed?
Yes, sir. Yes, sir.
Okay. Do you have NCRT right now, Asu?
Yes, sir. I have.
Okay. Come to page 538.
What?
Come to page number 538.
1 second.
Let's solve the whole exercise now. Also, whatever is written here is nothing but favorable upon total. These are favorable events, A intersection B, and these are total events. Favorable upon total. G, have you reached?
Yes, sir.
Okay. So let's solve question number 1. Probability of E by F and probability of F by E. And have you written this, Nasir?
Yes, sir.
So in first question, we need to find probability of E by F and probability of F by E when you have been given certain things. You have been given PE, PF, and PE intersection F. So can you find out using these three things? Can you find out PE by F and PF by E? I mean, can you find out means
Sure, sir.
I don't want you to first find out, but can we find out? We do we have enough variables to find out?
Yes, sir. We have.
Okay, let's try then. What would be PE by F? Solve with me. Tell me. PE by F.
P intersection. E intersection F.
divided by
F.
PF. Yeah. It can be either PF, that is probability of F. It can be either NF, that is number of elements in F. If there is probability, then both have both, or both can also have the number of elements in A intersection F and number of elements in F. But because we are not given the number, we are given the probability, so we can use the formula in terms of probability. No worries. Yeah. So probability of A intersection F would be
0.2 by 0.3.
Yeah. Right. It should be 2 by 3, and the next answer should be 2 by 6, 1 by 3. Okay. Okay, solve question number 3. Solve third question. And if you have any problem, please ask me. Otherwise, tell me the answers. Well, let's see how much did you understand the formula part.
Zero 0.32 for first one.
Which one? Also?
First one, A intersection B.
No, just a moment. Okay. What's the answer of first question?
0.32.
Correct.
Second one, 0.32 by 0.5.
Yeah, we can also calculate that, and it will come out as 0.64. But it's okay. You can leave that here too. But not like that. You should have written it 32 by 50. And then you should have solved it to 16 upon 25. That should be the correct answer. Either
Okay.
you should write 16 by 25 or 0.64. One of the one. One of among. The third one.
0.98.
0.9.
98.
Yeah, correct. Solve question number 4. Okay, take these questions. Fourth, sixth, ninth, 10th. Fourth, sixth, ninth, 10th. We're going to solve these questions in the class only. You can start solving 4. In question number 4, Nasir, what is the probability of A? What is the probability of A in question 4?
5 by 26.
Yeah, correct. That was the only catch. You should solve this question right. You will be able to solve this question. Okay.
Eleven by 26 is the answer.
What is the answer?
11 by 26.
7 by 26. Oh, no, I don't think so.
11, 11.
5 by 26.
11, 11.
What?
11, 11.
11 by 26, I think. It should be 11 by 26 now, sir.
So that's what I told.
Yeah, good. Now come to question number 6. Solve second part. Or solve any one of them. Solve any part. Any one part, bas.
Okay, sir.
Which one are you solving?
Sir, sixth one itself. First one, sorry.
First part, second part, third part.
First one.
Oh. So what are the possible cases in E?
Sir, it's HHH, HTH, THH, and TTH.
And what are the possible cases in F?
Sir, come again.
What are the possible cases in F?
Have two cases, sir. HHH, HHT.
Yeah, correct. So what is the possibility of E slash F? I mean E by F.
4/8. Or 1/2.
Why 4 by 8?
Sir, E intersection F is 1/8, and P of F is 1/4.
Intersection F is only one case, no? H.
Sir, one more is there. HHT is there.
No, why HHT? HHT is not in E. HHT is not in E. Why is it? Why it can be? How it can be in E intersection F?
Sorry, sir. It's 1/8.
So it will be 1 by 2. No? We need to find P E by F. So F will only decide the sample space, no? F has two elements. So the sample space is 2. Now P intersection F has one element. So the answer is 1 by 2. Answer is correct. But not with the explanation you gave me. It should be 1 by 2, but with this explanation.
Okay, sir.
P intersection F divided by PF. No?
Yes, sir.
And E intersection F will be one case and F is two cases. F has two cases. So it should be 1 by 2. Okay, solve third. Sixth question, part 3.
Sir, 6 by 7.
6 by 7. Okay. Just 1 minute. Okay. Yeah, correct. Good. Solve this one. 10th first part. No. Second part of 10th question. B. B part. Solve B part of it. There are two events here. First event is obtaining the sum 8. Obtaining the sum 8 can be done by 4 ways. 3, 5, sorry, 2, 6, 3, 5, 5 ways actually. 4, 4, 5, 3, 6, 2. And another event is red die resulted in a number less than 4. The number on red die is less than 4. Black die can have any. So there are two events. We need to find the probability of obtaining the sum 8. Means obtaining the sum 8 is event A. And red die resulted in a number less than 4 is event B. We have to find probability of A by B.
One by 9.
Yeah, correct. Can you solve this for me? Question number 12. Okay, don't solve question number 12. First solve question number 14, but don't use your pen. You have to calculate it in your mind. Question number 14. Two numbers appearing on throwing two dice are different. This is given. Means this is event B. Event B is two numbers appearing on throwing two dice are different. How many total possible elements are in this event? Total possible outcomes of the event. Tell me first this. Okay, there are how many events possible in a when we throw two dice? 36, right? If the numbers appearing on both dice are different, how many possible events do we have? Nasir, am I audible?
Sorry, your break.
How many possible events do we have? How many possible outcomes do we have if the numbers on two dice are different?
Sir, 30 outcomes.
Right. Now, he has asked the probability of what? The sum of the numbers on the dice is 4. So what are the favorable cases? How can we get in sum 4?
Sir, 1,3, 2,2, 3,1.
And how many will be in intersection? How many are favorable outcomes in these three, out of these three?
1 by 3 and 3 by 1.
Sorry, come again.
1 by 3, 1,3 and 3,1.
Yeah, correct. So there are only two possible outcomes, right? So the probability should be what? 2 by 30? Am I correct, Nasir?
Yeah, yes, sir.
Yeah. So the probability will be 1 by 50. It's easy. Conditional probability is very easy. But we have to use this for the further topics. So complete this exercise in the next class. You can ask your doubts, okay? And
Okay, sir.
we'll solve exercise 3, which will be a better exercise. It will be a tough exercise as compared to this. Okay?
Okay, sir. Okay. Bye.